Well, good morning, everybody. This is Dr. Krofchek, and today, while I'm not here, I'll be here in spirit, and you're watching this video that's on the srcs6math.blogspot.com. Doing lesson 57 today, and it's about adding and subtracting fractions, and they have a three-step approach to book teaches, and we're going to teach you something similar to that, I guess. We'll cover the book's way of doing it, and then I'll show you the way that I learned it back when I was your age. It's a relatively easy concept to understand as long as you're okay with fractions, because that is what we're dealing with today. And let's make sure we remember something when we're talking about fractions. If we're adding something like 1/2 plus 2/3, here's what you want to remember when we're adding or subtracting these fractions. Remember, the denominator has to be the same. Okay, we have to have the same denominator. So right now we cannot add 1/2 and 2/3 because our denominators are not the same. We have to make them the same. We have to, and they obviously have to be the same number. We want the lowest number possible, and we want a number that is that is a multiple of both 2 and 3. All right, that's what we're looking to do. So there's two ways you can go about this. I'm going to show you what I think is the easiest way to do this, without a doubt the easiest way to do this. When you are trying to get a common denominator, what you want to do is take the multiples of each denominator and then find the least common one. So as I'm looking at denominators or multiples of 2, I'm going to write a 2 up here, and I'm going to put down that we have my multiples, of course, would be 2, 4, 6, 8, 10, and 12. For my multiples of 3, it's going to be 3, 6, 9, 12, and then 15. And I'm looking for the first common multiple in this list of numbers. So I see that here's a 2, there's no 2 here. Here's a 3, there's no 3 here. Here's a 4, there's no 4 here. And then lo and behold, here is a 6, and there is a 6 right here. So that becomes my least common multiple, and that is going to become the denominator for my problem. So now this problem that I have, that is 1/2 plus 2/3, I'm using this 6 as a denominator for both of these problems. Okay, and then what I'm going to ask myself, there's two ways I can do this. I can say 3 or 6 divided by 3. How many times does 3 go into 6? 3 goes into 6 2 times. 2 times 2 is 4. Okay, I can do it that way. 2 goes into 6 3 times. 3 times 1 is 3. Okay, I can do it this way. And when I do that, look what happens. Now I have a common denominator of 6. So in my answer, I'm going to have a 6 in my denominator. Because remember, when we're adding and subtracting fractions, we don't add or subtract the denominators. We're trying to get a common denominator, and that denominator stays through until our final answer. So all we're adding or subtracting is the numerator. And in this case, we're adding 3 plus 4, and we get 7. And then when you have an improper fraction like this, more times than not, you want to make it a mixed number. So you divide 6 into 7 and get 1 with a remainder of 1. So your answer is 1 and 1/6. So 7/6 can become 1 and 1/6. But what you really want to focus on in this problem is how you go from a 2 to a 6 and how you go from a 3 to a 6. All right. The other way you can do this problem, guys and gals, is, let me erase this really quick. Another way you can do this problem, and this is the way your book kind of shows you actually, is you want that equivalent fraction. You want to make an equivalent fraction from 1/2 and 2/3 that has a 6 in the denominator. So what your book tells you to do when we're talking about equivalent fractions is you want to multiply this fraction 1/2 and 2/3 by by something that will give you a 6. So we know that if I multiply 2 times 3, it's going to give me a 6, right? And we know that if we multiply a 3 times a 2 here, we're going to get a 6. And what you have to do is you have to have a numerator for this fraction, for this new fraction that we're creating, this equivalent fraction that we're creating. You need a numerator for that as well. And the numerator you use is the same number that's used in the denominator. In this case, a 3 and a 2. So when we multiply this, now in multiplication, remember when we multiply, you multiply the numerator across, you multiply the denominator across, and you get your answer. And now look at, because these are equivalent fractions, or the mechanics for an equivalent fraction, the equivalent fraction is actually our answer over here. This, what I just put in this box for you, is what's allowing us to have these equivalent fractions, because 3/6, right, is the same thing as 1/2, isn't it? And 4/6 is the same thing as 2/3, isn't it? I can reduce this down to 1/2. I can reduce this down to 2/3, right? So hopefully you see that. And so that's another way we can do it. You can try to find the least common multiple like we did up here, or you can just say what number can I multiply each of my denominators by to give me the same number over here. And this is, but remember, what you use in the denominator you have to use in the numerator. You know, without looking at my book, I don't remember all these different properties, but I think this is the identity property of multiplication, I believe is what this is called. When you're multiplying by something that is an equal to 1 to give you an equivalent fraction. Okay, so that's what this is all about. That's the whole lesson, and that was actually example number 1 in our book today. So now I'm going to go ahead and erase all this stuff here. And we're going to get on with example number 2. And here, this time, we're going to take 5/6, and let me change my ink flow here. We're going to take 5/6. Now we're going to do some subtraction. We're going to subtract from that 1/3. And now, of course, right away you look and you say, we know when we add and subtract, what's the first thing we have to do? We have to make the denominator equal, the same. So, and you obviously you always want to look to see, can I use my biggest denominator as my denominator over here for my new fraction? And the fact of the matter is, if your larger number, and 6 in this case, is one of the multiples of your lower number, then you can use this bigger number. Okay, and I know that when I'm doing my multiples of 6, I get 6, 12, 18. I'm just going to do a couple. And when I do my multiples of 3, I get 3, 6. Well, bingo. I got my least common multiple right here. There it is. So I can use my denominator from this one problem. Now, let me go ahead and erase this stuff because it's going to be kind of in my way. All right. And let's look at this now. So we decided that 6 will be a common multiple, right? So I can put a 6 over here for my upper fraction. I can put a 6 down here for my lower fraction. And I can ask myself, how many times does 6 go into 6? 1 time, right? 1 times 5. 1 times 5 equals 5. How many times does 3 go into 6? 2 times. 2 times 1 equals 2. Okay? Now, I look and I ask myself, are these equivalent fractions? Is 5/6 equal to 5/6? Well, of course it is. It's the same number. Is 1/3 equal to 2/6? I can reduce this down to 1/3, can't I? So it's an equivalent fraction. So I'm correct. I'm absolutely correct. All I have to do is bring over the fact that I'm subtracting. So I put my subtraction operation signal over here, and I'm good to go. And I know that when I have my answer, once again, when I'm adding and subtracting fractions, I do not change the denominator. I do not add or subtract the denominator. I just did all this work to get it equal, so that's my job. I just bring it over. And now I'm subtracting 2 from 5, and I'm getting 3. And then this obviously can be reduced down to 1/2, because 3 goes into 3 once and 3 goes into 6 twice. Now, once again, let me erase this stuff in the center, and I'm going to show you the other way that you can do this. And this is the way we're talking about making these equivalent fractions. Now, this is something that we have to do. All right, so in this way, this process of doing this, we uncover the fact that 6 is going to work, right? We know 6 is going to work, and we want to multiply it by something that is going to give us 6. Well, obviously, 6 is going to have to be a 1, because 6 times 1 is 6. And what goes on the numerator, or denominator rather, has to go in the numerator, so we put a 1 up here. Then we ask ourselves the same question. 3 times what will give me 6? Well, 3 times 2 gives me 6. And then if I put a 2 here, I have to put a 2 here, because this fraction has to be equal to 1, right? Or the fraction here, right? Or this fraction and this fraction won't be equivalent if this is not a 1. So remember, this has to wind up being equal to 1. This has to wind up being equal to 1, and they are. So we multiply. 3 times 2 is 6, 1 times 2 is 2, and this is how we get this equivalent fraction, because once again, we know that 2/6 can be reduced to 1/3, and that's equivalent, obviously, and 5/6, because it's multiplied by 1, it's going to be the same. So that's the other way that we can set this up, guys. I hope that makes sense to you. If it doesn't, your substitute, I believe it's Mr. Woods, very, very capable, obviously, of helping you with this. So let's go ahead and do a practice set problem or two, and we're going to do this one. We have 1/2 plus 1/6. Now, sometimes your book likes to do this. They like to give you these problems 1/2 plus 1/6, and I just find it easier to put them in this column format instead of this row format. So anytime you get them in a row, I'd put them in a column instead. I mean, that's how I did it when I was a kid in school. Maybe the new math now, maybe there's a technique for teaching it, doing it in that row fashion. I just don't like it, so I always change them to columns. That's just how I did it. It's how I prefer to teach it. So you do, hey, listen, you know what? You do whatever works better for you, whatever's more comfortable, whatever makes more sense to you, obviously. As long as you're doing the operations correct, you're going to wind up with the same answer. But look at this problem here. You know what we have to do is we have to find out what our multiples of 2 and 6 are. And our multiples of 2, obviously, are going to be 2, 4, 6, 8. My multiples of 6 are 6, 12, 18. What's my first common multiple? Well, look it's staring at me in the face. It's a 6. 6 here and a 6 here. So I'm going to use my 6. I'm going to put a 6 in the denominator. I'm going to put a 6 in the denominator. And then I'm going to say, what times 6 will give me 6? And that's going to be 1. So I have to put a 1 here. What times 2 will give me 6? And that's going to be a 3. So I have to put a 3 here. 6 times 1 is 6. 1 times 1 equals 1. 2 times 3 equals 6. 1 times 3 equals 3. All right, guys, so that was the last sample problem I'm going to do today. Mr. Woods, if he's subbing, can obviously more than qualified to do the rest of these with you, and I'm sure he'd like that. So, Mr. Woods, take over if you're here today. If not, whoever the substitute is, just let the students work on their own and do the practice set, which is, let me put on my eyeballs, A through F, and then written practice 1 through 30 on page 296, 297, and 298. All right? Hey, have a great weekend. See you on Monday.